Let's talk about that invisible force that's running in the background of your life. You know, the one that decides what movie pops up on your screen, what news you read, and even what snacks you might buy right before a big storm. We're talking about data science and how it's making sense of the absolute digital flood that we're all living in.
Okay, so let's just dive right in. Before we can even get to the science part, you have to get a handle on the sheer scale of the data. And honestly, the numbers, they're just staggering.
Just take a second to look at that number, 2.5 quintillion. What does that even mean? It's a 25 with 17 zeros behind it. And that's how many bytes of data we, all of us on this planet, are creating every single day. To put that into perspective, if every one of those bytes was a gallon of water, you could fill the entire Amazon River 50 times over, daily. And the wildest part? That fire hose of information is just getting faster.
So you have to be wondering, where's all this data actually coming from? Well, just look around. It's the Internet of Things. You know, your smart speaker that's connected to your coffee machine. It's your car, which is constantly sending back information. And then, of course, you've got the really obvious ones. Every post, every tweet, every online purchase, every single show you stream. Every little click you make just adds another drop to this massive digital ocean.
But here's the thing. It's not just the amount of data that's exploded. It's the kind of data. Back in the day, most data was neat and tidy, stuff you could put into a spreadsheet. We call that structured data. But now we're living in a world of total chaos. We're talking photos, videos, voice memos, social media comments. It's all just a big, unstructured mess. And you can't just plug that into a simple table. You need totally new, way more powerful methods to make any sense of it at all.
So we've got this gigantic, messy ocean of data. How in the world do we find the valuable pearls hidden inside all of that? You know, how do you separate the actual signal from all the noise? Well, that is the exact problem that data science was created to solve.
At its heart, data science is really just the art of being a detective. A data scientist is someone who sifts through all the clues, all the purchase histories, the user clicks, the sensor readings, to find these hidden patterns. And finding those patterns helps businesses, scientists, and, well, pretty much everyone make smarter decisions based on actual evidence.
And here is a fantastic and kind of weird real-world example of that detective work. By digging through mountains of their sales data, Walmart found this bizarre connection. Right before a hurricane is about to hit, sales of strawberry Pop-Tarts just skyrocket by 7 times. I mean, nobody would have just guessed that, right? But it was a real pattern hiding in the data. And that little insight allowed them to stock their shelves ahead of time. That's the power of data science.
But, you know, a detective needs their tools to process all the clues. For a data scientist, the most powerful tool in the kit, the real engine that drives all this discovery, is a concept I am positive you've heard of: machine learning.
So what exactly is machine learning? Well, in a nutshell, it's a way of teaching computers to learn from data without having to spell out every single rule for them. So instead of a programmer trying to write code for every possible thing that could happen, they build a system that learns patterns from experience. It gets smarter and more accurate the more data it sees. You know, kind of like we do.
But this whole idea of learning can happen in a few different ways. So let's quickly break down the 3 main styles, or as some people call them, flavors of machine learning.
First up is what we call supervised learning. The best way to think about this is like you're teaching with flashcards. You give the computer a huge set of data where you've already provided all the answers, like millions of photos that are clearly labeled cat or dog. The machine just studies all those examples until it figures out the patterns, you know, whiskers, pointy ears, that kind of thing, so that it can correctly label a brand new photo all by itself.
Next, we have unsupervised learning. Okay, for this one, imagine dumping a giant box of mixed-up Legos on the floor and just saying, sort these out. There are no instructions, no labels. The whole point is for the machine to find the hidden structures on its own. Maybe it'll group them by color or by shape. Businesses use this all the time to discover natural groups of customers based on their buying habits, without having any idea beforehand what those groups might be.
And finally, there's reinforcement learning. This one is all about learning through trial and error. It's almost exactly like training a pet. You have a program or an agent that tries to do something, like get through a maze. If it makes a good move, it gets a reward, a little digital treat. If it makes a bad move, it gets a penalty. And after millions and millions of tries, it eventually teaches itself the absolute best way to solve the maze to get the most rewards. This is actually the same technique we use to train AIs to master incredibly complex games like chess.
Now, I know all of this might be sounding a little abstract, But the truth is, you are interacting with the results of data science and machine learning constantly, every single day.
You know when Netflix recommends a movie and you think, wow, how'd they know I'd like that? Yeah, that was not a lucky guess. That's its powerful recommendation engine. It's analyzing everything you've watched and comparing it to millions of other users with similar tastes. It is so good at keeping you watching that Netflix figures that system is worth over $1 billion a year.
Or how about when you upload a photo to social media and it instantly suggests tagging your friends? Well, that's a perfect example of supervised learning right there. The algorithm has been trained on literally billions of photos that people have already tagged. It's learned to recognize the unique patterns of a person's face from all sorts of different angles and in all kinds of light.
And that nice, clean inbox you have, you can thank machine learning for that too. Spam filters are constantly learning. They analyze trillions of emails to spot the patterns. The weird phrasing, the sketchy senders, the bad links that scream junk mail. It's a little supervised learning model that's classifying every single email that comes in as spam or not spam, and it saves you from a ton of garbage. And of course, Amazon's legendary "customers who bought this also bought" feature. This is probably the most famous example of unsupervised learning. Nobody tells the algorithm what to look for. It just plows through billions of transactions and discovers on its own which things are frequently bought together. It sounds simple, but that little feature is a powerhouse. It drives as much as 35% of Amazon's total sales.
So there you have it. We've gone from this chaotic flood of raw data to this incredibly powerful set of tools that are actively shaping our world every day. Data science is way more than just technology. It's a completely new lens for understanding everything around us. And that brings us to the biggest question of all. Now that we have the power to find almost any pattern and predict almost any future, what should we ask the data to predict for us next?